All right, video number 3, super short again, talking about heat energy today. So the first day we filled out our ISN, we filled out this acronym that said WHAM, W-H-A-M. Okay, we're on to the H. H stands for heat energy, because this is what causes weather, is WHAM. All right, those are the factors that cause weather. And so heat energy is really like the main driver of this whole thing. If we didn't have heat energy, we wouldn't have weather at all, okay? And so heat energy is measured by temperature. Very simple. Everybody knows that it's hot outside, it's the high temperature. It's cold outside, it's low temperature. Very simple, okay? Now, there isn't a section in the book here on heat energy, so I'm just going to talk about it real quick, and then I'm also going to talk a little bit about humidity and dew point. So bear with me. So heat energy is the main driver of weather. Okay, heat energy from the sun heats up the earth, heats up the surface of the earth, the land, the air, causes convection currents going in a circle. Heat makes the air warm, it rises up, cools down up in the atmosphere, and then sinks back down. It just goes in a big circle. We learned about this already, convection. Okay. So one thing that I haven't really talked too much about is humidity. I briefly mentioned humidity and like relative humidity and stuff. And humidity, nobody really likes it. It's like the worst thing for weather. So it's the amount of moisture or water vapor in the air. And usually humidity level is reported in relative humidity. The newscasters being, yes, the humidity is at 70% today. Very humid outside. Okay, you don't really understand what that means. That means that the air is holding, out of the whole amount of water that the air can hold, it's holding 70% of the total amount. If I had a glass, right, and I filled it up 70% of the way, it would have about like that much stuff in it. So imagine that this glass is air, is the body of air outside. If it was 70% humidity, this glass of air would have this much water in it. Okay? So it's very humid. When you get to 100% relative humidity, the water is totally full of air, it rains. Okay? Or precipitates. It could happen in the wintertime and make snow. And so once it reaches 100%, the air is completely saturated. The air molecules can hold no more water. Stop it. It can hold no more water vapor. It turns into rain at that point, okay? And so another thing that heat energy has to do with this is that, like we said earlier, I don't know, last week, maybe the week before, warmer air can hold more water. So that's why it's super humid down in places like the DR and out in like the rainforest and stuff. It's super warm there all the time. It's very humid because the air is so warm. The more heat energy that it adds, the more water it can hold. That's why it rains there a lot too, because it's so humid all the time. So there's more water vapor. So right here it says, so there is more water vapor in 50% humidity warm air than 50% humidity cold air. Now what does that mean? Okay, so like, where do I have a big container? I do have a big container. Boom. All right, so I have this big old blender bottle, right? So imagine this is warm air in Florida, okay? It's hot, can hold a lot of water inside, okay? But then I have this little container, much smaller, right? This is, let's say this is air in Michigan, all right? Might not be super warm. So like right now, it's the end of September, early October almost. Florida is still going to be nice and warm, and it's still going to be able to hold a whole bunch of water, okay? Michigan right now is cooling off. So we're not going to be able to hold as much water in our air. So if this Florida one was filled up 50% of the way, and this one for Michigan was filled up 50% of the way, which one's going to have more stuff in it? They're both filled halfway to capacity, halfway of how much they can both hold. But one of them, this one, is going to have more stuff in it because it's just physically larger. If I took a whole big trash can and fill it up halfway, that might be 10 or 15 gallons. But if I fill this up halfway, that's only a few ounces. Okay, they're both still filled 50%, but one is much bigger and can hold so much more. And that's how relative humidity works. Okay, the warmer the air is, the more stuff it can hold, the bigger the container becomes. The colder something is, the smaller the container becomes, the less it can hold. Okay, dew point, very simple. It's just the temperature at which water condenses and then forms dew on the grass. That's it. It's very easy. So like, you don't see dew on the grass all the time. Like during the day, there's no dew on the grass. It's too warm out. But it happens in the morning when there's water vapor in the air and the air at the ground is cold enough. Normally, dew point happens like up in the sky where it's cold and the water condenses and become droplets. Dew point happens down at the ground level when the air is cold enough, it condenses, and then you get water on blades of grass. It's kind of like a cloud almost, just condensing out and being on blades of grass. And that's really all.